We are very lucky to have with us today Mr. Paul Grives, Global Industrial Strategy Advisor, ExxonMobil Fuels, Lubricants and Specialty Marketing Company. He has more than 23 years of experience and in-depth expertise of industrial greases and their application. In his current role, Mr. Grives oversees the marketing and product development of the company's industrial grease portfolio, which includes ExxonMobil's popular lineup of high-performance Mobil SHC branded synthetic greases. He's here with us to share insights on getting smart about grease, which will focus on the call for global minimum specification for greases, helping the industry to be smarter and more efficient in certifying greases. First off, can you explain the basic properties of grease and why is it so important for industrial equipment?
Sure, an excellent question. The best thing to think about, or the easiest way to think about a grease, is to consider it as a sponge. So as a sponge is a multi-component system, so is a grease. And when there's an external stress, such as vibration or rotation, the sponge is squeezed, releases the oil, and the oil does the lubrication. In a similar manner, a grease comprised of a thickener system, or a sponge, saturated with oil, serves to lubricate rotating or moving equipment.
What do you see as the key challenges faced by industrial companies today?
Interesting question. The two biggest things that continue to affect industrial companies today, the first is the concept of increasing power density. And what I mean by that is equipment getting smaller, having to operate faster, hotter, to produce the same amount of output. This puts additional stresses on the lubricants and the greases, requiring them to be more robust in their performance profile. They have to perform at a higher operating temperature. They have to perform for a longer period of time. The second aspect that is really affecting industry today is the continuing drive towards energy-efficient lubricants. So lubricants that not only reduce friction, the basic of all lubrication science, but also help to conserve the amount of energy that's used to cause that rotation.
How to ascertain whether to use grease or oil lubrication?
Greases and lubricating oils, although it is the oil in the grease that does the lubrication, there are certain instances where it is preferred to use a grease rather than the oil. Cases such as difficult to reach or hard to lubricate areas are better lubricated with greases than with oils. Vertical applications, where the grease is held at an elevated level. You can imagine trying to put oil into a bearing up above your head, we would all be covered with oil. Greases also have a unique property, and that is that they act as their own reservoir of future lubrication. So when I take, for example, when I take a lubricant, a fluid, and put it in an application, all of that fluid is in that application immediately. When I take a grease and put it into an application, that sponge holds back as a reservoir of future lubrication oil and additives to be released only when the application requires. When you first started, you asked me about getting smart about greases. Well, you know, we consider greases to be smart in that they understand the needs of the equipment. By developing them and manufacturing them correctly, one can control how much oil is let out so that the smart grease can go ahead and release just the right amount of lubrication to solve the problem, to lubricate the part, but maintain a sufficient background, a reservoir, to enable long-lasting performance.
How can manufacturers ensure that their lubrication needs are being met through greasing?
This is more and more of a challenge as industries continue to coalesce and original equipment is manufactured in many times very far from where it's actually installed and operated. So how does a manufacturer of equipment here in India guarantee that when they sell their equipment and it's installed in Finland or installed in Canada, that it performs exactly as the original equipment manufacturer developed it? One way is to put specifications or requirements around the lubricants defining the minimum performance set that's required to enable the equipment to operate. One way to do this in a simple manner is to go ahead and adopt one of the current industrial grease standards out there, such as DIN or ISO, which is a naming scheme that encompasses many different test criteria put together in a very simple, easy, well, shouldn't say easy to understand, but a simple by virtue of number of characters but meaningful code that will translate and tell the customer the kind of grease to use, the performance properties that the grease should have, and in some cases even the operating temperature range. So how hot versus how cold can this grease actually perform?
Can you give an example of how a DIN or ISO code denotes application and performance information about a grease in a simple code?
Let's consider an equipment manufacturer that has a piece of equipment that requires grease in a bearing. And they say that the minimum specification or requirement for that bearing is that the grease meet the following DIN. So DIN 51825 is the DIN standard, and then the test code would be KPFHC2N-40. Now, not simple at all, right? But if you know the code, those letters and numbers tell you everything you need to know about that grease. K signifies that this is a grease that is developed for plain or roller bearings or slideways. PF tells me that that grease must contain EP anti-wear additives as well as solid load carrying additives, so a grease that can carry high loads. HC tells me that that grease must be formulated with synthetic hydrocarbons, so not a mineral oil-based grease. 2 is the NLGI penetration code. So an NLGI 2-grade grease is a soft, buttery consistency. N is one of the most interesting components of that code. N it designates several things. It designates the upper operating temperature. In this case, N signifies 140 degrees C, upper operating temperature. It also signifies that the grease contains less than 0.4% water. It also signifies that the grease has less than 25 milligrams per kilogram of particles. And on top of that, it tells me that this grease has good rust and corrosion and also great water tolerance. And then the minus 40 is the lower operating temperature. So that number tells me that down to minus 40 degrees C, it is expected that this grease will continue to lubricate, release oil when that stress is there, reabsorb it when that stress is removed, continually in operation. So that simple code, I'm smiling again, but that simple code, KPFHC2N-40, really defines precisely what that grease can be, needs to be. And by accepting this and by specifying the lubrication products by these codes, an OEM can guarantee that a user, so the person who buys the equipment, can access that product and get the best operation out of their equipment. And what I mean by this is the equipment builder no longer needs to go out and individually certify unique products from many different unique suppliers. All they need to say is the grease must meet this set of specifications. As the customer who needs to purchase the product, they no longer need to go out and do field trials and testing on their own account. They can say to their suppliers, Mr. or Mrs. Supplier, I need a grease that meets this claim set. Now, from a supplier perspective, this is not eliminating our ability to differentiate or our ability to show extra value to our customers. What these specifications are minimum performance requirements. They still allow suppliers to provide products and services to customers that exceed these minimum requirements. So it levels the playing field. They establish a very transparent way of signifying what the performance characteristics of a product should be, both greases and there are similar coding systems for lubricants, but it still allows a lubricant supplier to create extra value for the customers by exceeding these minimum requirements.
With the need for high-performing lubricants, how does ExxonMobil approach its process of developing the right lubricants for its customers' needs?
Sure. At ExxonMobil, we view the product development cycle as exactly that. It's a cycle. It always starts with the customer. By deploying a large field force of equipment builder engineers as well as field engineering services engineers, we touch our customers and we find out what are the trends in industry from equipment builders. We ask our customers, what is important to you from a lubrication perspective. That information is fed back into our research facilities where products are developed to meet those defined customer needs. That product development encompasses both laboratory glassware bench testing. Once that's completed, it moves to bench and rig testing. This then is a cycle. Until the bench and rig testing is acceptable, we'll continue to go back to the glassware. At the point that that bench and rig testing has been successfully completed and meets all of our expectations, we'll then move to field testing, where we go back to our customers. We let them know that we've heard what they've asked for, we provide them samples, and we ask them to test the product in actual application. That then again is another feedback loop. If the product fails to meet their expectation, we take that feedback, push the product back into research, and recycle again. If the product meets that expectation and we've now proven performance, we can then go to commercialization. In commercialization, the process doesn't stop. As that product is out in industry, our field engineering services folks, our sales engineers, our partners and our distributors continue to touch the customer on an everyday basis to continue to monitor. Are these products performing as we promised? Are they meeting your expectations? Do they need to do something else? So in this cyclical manner, we're able to try to always stay lockstep with the needs of our customers, creating the greatest value. And it's this way that ExxonMobil and our product offer, the mobile industrial line of greases and lubricants, can really create and do create the most value for our customers.
What is ExxonMobil's relationship with key grease industry groups like NLGI?
NLGI, or ExxonMobil, is a strong supporter of industry groups such as the NLGI. One of the reasons that I'm in India here in February is to attend and present a paper, a technical paper, at the NLGI India chapter meeting in Kovalam. We feel that industry organizations such as NLGI or ASTM or even DIN or ISO are very important in establishing a level playing field for all manufacturers. And it also provides a great forum for communication and interaction to learn what are those next best practices. What's out there that the industry as a whole sees. So we're extremely supportive of industry organizations such as the NLGI.
How do your greases differ from those of your competitors?
I'm very proud of our greases, and as you said, I have over 23 years of experience with ExxonMobil. All of it, except for 6 months, has been involved with some aspect of greases. I've developed greases, I've manufactured greases, I've done technical service for greases, I've built grease plants, and I've shut grease plants down. And today I'm sitting here and I market greases. So how do our greases differ from others? I think there are at least 3 basic key differences between our greases and everyone else's. One is our extremely strong relationship with the original equipment builders through our EB group, and that continuing extremely close relationship with our customers through our field engineering services group. Our research and engineering department is extremely focused on manufacturing the highest level, highest quality products. Now, I'm not saying that everybody else doesn't also have a research and development facility. What I'm saying is we have many, many years with many breakthroughs and patented technology on greases that have been commercialized to provide that greatest value. And then the third part is our advantaged engineering. We employ both patented manufacturing technology as well as patented compositions to provide greases that are unique in the marketplace. And it's in this way that we feel that we can differentiate our grease's performance. Lastly, and definitely not least importantly, is our very close relationship to ExxonMobil Chemical Company, as well as to the large selection of additive suppliers, allows us to use those cutting-edge, leading-edge components to make those greases that perform the best.
What is your message to the Indian manufacturing companies?
My message to the Indian manufacturing companies is to sit back and take consideration that the world is truly a global place, and that by embracing methodologies to clearly identify lubricants in a way that they are readily understood wherever Indian manufactured equipment is moving to is really critical to maintaining India's quick growth, far exceeding TID, total industry demand, of the rest of the world. So as India continues to grow and Indian manufacturing continues to grow, assurances need to be made that the equipment that is made here and shipped other places can still be lubricated and operated exactly as designed here. And that really goes for any area of the world where equipment is being manufactured. We are truly a global industry. And as equipment moves around and industry moves around, from a lubricants perspective, it's important that we're able to provide the right lubrication for that equipment so that that equipment operates exactly as the original equipment manufacturer designated it to.